Hey everybody. Well, I'm going to take a chance here. Had an early day and I got home a little bit early for once on a Friday, which is great. But of course my phone's been blowing up from work, so I'm going to try to do this and we'll see how much the phone stops me today. But anyway, where we are with this video is we're going to rebuild this board right here. We did the other one, we finally got it working, we got all the bad juju out of it, and after putting some transistors in backwards, we put them in the right way and everything worked good. So what we're going to try to do now is replace the same components on this to make the two boards identical, and you kind of know my thoughts on that. I always like to do that just so I know they're both the same, and then we'll give this board a bench test, make sure that it's functional, and then once we do that, we'll get it put back into the amplifier and it'll be ready to do the front end, which is going to be the biggest job of this whole project, is the preamp section, because all the switches are all gummed up on it, and it's just the preamp is a kind of a mess as far, especially with the mechanical parts. So we're going to have to go through and disassemble all that, which is going to be a little tricky, and go over the process of cleaning and restoring that. So if that sounds good to you, stay tuned, and that's what this part's going to be about. Now, before I get started, I don't know why these are the most popular thing on my video. These little alcohol dispenser pumps like that, and everybody asks where I get them. And well, I could have a little fun with you and tell them that when I went to my doctor's for a checkup, I stole them from him. But but actually, these just came from eBay. You can get them from eBay, and you can get them from Amazon. You can also get them from AliExpress and those kinds of places. They're very, very inexpensive. If you just look up alcohol pump dispenser bottle or something like that, you'll get all kinds of hits. And there's several different versions. This one is my favorite. It's all plastic, but it is actually really good quality, just the kind of plastic they use. There's this kind that's kind of the flimsier plastic, although it works pretty well also. You can see the top on it, and these all pump, you know. And then there's these old-fashioned style that have the plastic base, and they have the metal top, and these are good, but the metal kind of gets corroded sometimes and it jams up. But all three of those, you know, they're not expensive, a few dollars a piece. And I have some of them with alcohol, and some of them, one of them I keep acetone in if I want to clean paint or clean something like that off of something. And they're just handy to have, and I use them. So I hope that takes care of it for all of you. Now, the one thing I want to talk about the most in this part of the video is the transistors and some of the substitutes. This amplifier is a little bit of a challenge to find proper substitutes. Now, of course, you know, I went on Audio Karma and somebody put something on the internet, you know. Yes, you can do that. But I'm going to show you why that's not always the best idea, and that you can't just be a Google scholar all the time for everything. You still have to do your research yourself and do your work and learn things. You know, I think we get too complacent because of the internet, and quite often I hear a lot of people just quote something that they randomly read somewhere on the internet as if it's gospel. And the bottom line is, sometimes the things that you hear out there, you're either reading it out of context, or perhaps it's something that's flat out wrong, or it's something that is actually correct. The problem is being able to discern that. And just because somebody replaces one type of transistor with another type, it doesn't mean that if that one type of transistor is used in a different circuit, that other replacement transistor will still work. There may be slight differences, and those differences might be important in one circuit and they aren't in the other. And we're going to talk about that. That's the big thing I want to go over when we do this, because really this is going to be nothing but unsolder some parts and solder the new ones in. But the transistor part, I think, is a little bit interesting. I am by no means, an expert on that. There are people who really understand it at the physics level that I don't understand it, so I kind of know enough to be dangerous. But I'll share with you what I know, and any of you out there who are more well versed in transistors, feel free to add on to this, and then we'll all have a resource on this channel to be able to exchange some information. Okay, I have the screws out. Pop this off. I just love the way this thing is put together. Just as easy as this amplifier module is to service, that's how difficult I think that preamp module is going to be to service, because it doesn't look as easy. It is modular, but it doesn't look nearly as simple as this. This is a great design. I love this design of this amplifier module. And again, this one works perfectly. I tested it and it passes a signal. There's no DC offset at all. There is, the bias is working properly. So we really, all we're doing is maintenance, I'll call this. We're going to clean it up, remove the glue, new capacitors. We're going to replace some of the transistors and leave some of them, and verify all of the resistance of the resistors, and we're just going to call this one done because it's working. It really doesn't need any more service beyond that. Okay, a little tip for all of you. If you're working on a stereo amplifier, it means you're going to have to do everything twice. One for the left channel, one for the right. So what I do is when I'm restoring one of these, now some people will go through the schematics and they'll make a checklist and they'll write everything down and make a grocery list and order it. A lot of the things I have in stock, so I don't do that. But what I will do is whenever I restore one side, I'll pull two of everything. So if I'm going to replace this capacitor, I'll grab two of them out of the bin. I'll put the one on the board. I'll put the other one in a little container like this for the other channel. When I'm done, I will know everything that I replaced on the other board, and I will have another copy of it here so that it makes it very easy to rebuild the second board. So you know you're replacing everything with the same components on both sides. Okay, capacitors are replaced, and I am going to now replace this differential pair, this dual transistor package. This one is good. It's not bad. Doesn't seem to be bad, but after speaking with the owner, he feels that it would be a good thing to do to replace it with a brand new one, because these tend to develop shot noise with age. I've had several of them do that, and of course I've just replaced them with two matched transistors, and you can do that. But since we wanted to keep everything the same and he was willing to go the little extra money for it, we're going to replace it with an original component. I'll show that to you here in a second. Anyway, this is what a 2SC2259, and a genuine one, looks like. This is a real one. It's new old stock. You have to be very careful when you buy these. Number one, you can get them on eBay, and quite often, but not always, they can be fake. They won't always be, but they can be. Second of all, you can get one that is genuine, but I've seen them, and I have some somewhere, I have to find them, where, for instance, this one, I believe the emitters are tied together and connected to the center pin on this. I've had other ones where the collectors are tied together. So the pinout is different on them, even though they have the same number on them. And I don't know if it's because they were a different manufacturer or because they were a counterfeit. I don't know. But you have to be very careful, and you always want to measure them. So the emitter is in the center of this, and I'll just kind of show you how we will verify that the emitter is in the center on this one as well. We'll go into diode mode, and this is a dual NPN transistor. The base is connected to the two outer pins. So if I put the positive lead on the base of this side, and I go to the center pin, which is emitter, I should see a diode drop, and I do. Do you see that? I don't know if you're there. Okay. So if I go from here to here, I get a diode drop. And if I go from positive on the other side to the center pin, I should also get a diode drop, and I do. In addition, if I put the positive on the outer lead and go to the lead next to it, I should also see a diode drop, and this is hard to do around the camera, but I'll see if I can get it for you. You could see it there, and the same thing over here. So that shows that this is the correct polarity in the correct transistor. And then, of course, if I go from emitter to collector on either side, it should read as an open circuit, and it does. So this is a good transistor as far as we know, I mean, without curve tracing it or something, you know, crazy like that. And it is the correct pinout and the correct polarity. And you just have to make sure that it's wired like that. So I'm going to get that mounted, and I'll get a piece of heat shrink over it. And I believe the reason that they have the heat shrink on there is to add a little bit of thermal insulation to make these less susceptible to outside air and so forth. You know, this was factory. This is how this came from Marantz. So we're going to repeat that. In addition, we also have these dual J-channel or N-channel MOSFETs, or JFETs, I'm sorry. They're like a dual JFET in the pack, and actually one of these pins is not used. But this is an inline dual JFET module, and you can see it right here. Again, same thing. I have a couple of these, and you can also, there's another JFET pack that is readily available. I think you can still get them. And they are a direct replacement for these, a drop-in replacement. If you can't find these what are they, 2SK109s. So I'll see if I can find them. If I can't, then we'll have to, guess you'll have to take my word for it. But there is another type that will drop in and replace it. I think these are it. Here, I think I found them. Yeah. These ones are, you can see, UPA 68HA. Those are it. The UPA 68HA. Those are a direct drop-in replacement for these, and they will work just fine in place of it. And these are a lot more readily available still than those other ones, than the 2SKs. Or the 3SK, I'm sorry. 3SK109. I think that's what those are. Anyway, we're not going to replace those because, again, those are pretty bulletproof in there, and I don't think we'll have any problems with them. When they fail big time. Okay, and there they are, and we put some purple heat shrink on there just for fun, and also to kind of indicate that they've been replaced. In addition to that, you can use these NTE40s, and they are also a drop-in replacement for those dual NPN transistor packages. And you can see they look, I have a few of these, and they work just fine also. They're same specs, they'll work perfectly. Don't be afraid of NTEs. The only time you have to be afraid of them is sometimes with some transistors they'll do a replacement one it's not necessarily a lower quality transistor, it's just the wrong specs. They're not exactly the same. They will work in most cases, but not in every single case. In other instances, when they're very special design like this, they're pretty much an identical replacement. Okay, we got this replaced. I'm going to take this off now, this little heat sink, and I'm just going to clean up the grease on these and put put some new thermal compound on them. This has gotten kind of dry and gross. So we'll clean that up. And this will be about ready. And I'll probably do this one over here as well on the bias tracking transistor. Let's see what we can do to clean this up. Let me get some of this off of there. It's kind of not in very good. It's getting kind of dried out. Probably still works okay, but hey, we're in here. We might as well do it, huh? Okay. Okay, as I promised earlier in the video, let's talk about transistors before we put this all back together, because this is kind of interesting stuff. First of all, this 2SA 949 and the 2SC 2229, you can see those are these bigger transistors here, and they work in conjunction with these guys here. They can be replaced with a KSA 1013 and a KSC 2383. So you can readily still buy these. They're a drop-in replacement. But here's where things get a little more interesting. The front end of this has a lot of these 2SA 970 transistors. I don't know if you could see that in the camera or not. Hopefully it'll focus a little bit. And also the 2SC 2240s. Or what is that? Yeah, 2SC 2240s. And those are, again, a complementary pair of transistors, PNP and NPN. And if we look at the 2SA 970, this has been around for a long time, and these are very reliable transistors. I hardly see these fail, although I'm not somebody that works on these day to day like some folks that work in a repair shop. But over the years, these seem to be, when I see them, they don't seem to fail. And if you look down at the specs, it looks somewhat familiar. Even, you know, it's 100 megahertz transition frequency, 120 volt breakdown voltages, you know, and so forth. And you might be inclined to say, well, that looks almost like a KSA 992. And indeed, when you look at it, they're very similar. You can see, when we line everything up, it's very close. But there's one thing you have to take a look at here, and that is when you look at the maximum collector current and the maximum base current. The maximum collector current is 50 milliamps on the KSA. It is 100 milliamps on the 2SA 970. The base current, again, same thing. 10 milliamps base current versus 20 milliamps. Now, when you look at the maximum power dissipation, this one has a power dissipation of 300 milliwatts. However, this one's 500 milliwatts, and a lot of times people will look at this and say, wow, this is a better rated transistor. It should be a drop-in replacement. And again, 100 megahertz, 100 megahertz. You can go down the line. They're pretty similar. There's really not a whole lot of difference until you look at that collector current. So I want to talk about that for a minute. Whenever you look at the maximum dissipation of a transistor, what they're saying is when you take the voltage that's applied across the transistor and the current flowing through the transistor, and you times those, it cannot exceed, in this case, 500 milliwatts, or a half a watt. And you would say, well, if this is a 300 milliwatt, this should just drop in and no problem. But let's do a little bit of math. If you apply 120 volts, collector base or collector emitter, at 50 milliamps. Right? Let's do it right on the camera here. 120 volts times 50 milliamps, 0.05. That is 6 watts. So how in the heck can this thing be able to do this? But they're saying it can only handle 500 milliwatts. Well, what they're saying is the combination of voltage and current, when you apply them together, cannot exceed a wattage of 500 milliwatts. So if the higher of a voltage you're applying across the transistor, the lower the current it can handle, and vice versa. And these are the do not exceed limits. So even if you're under 500 milliwatts of dissipation, you still cannot exceed 120 volts between the collector and emitter, or collector and base, and you cannot exceed 50 milliamps of collector current. Where that becomes an issue is, let's say we have a circuit that we're using this in that is lower voltage. So let's say maybe it's only 20 volts. So they're both of these transistors will work really well within that 20 volts, won't they? Because they can take up to 120. However, what if that circuit has 60 milliamps on it? Well, with a 60 milliamp collector current, this transistor, it'll probably run pretty warm, but it will work. It won't exceed the limit of the transistor, and it won't fail. Whereas with this one, it's exceeding the maximum collector current by 10 milliamps, and this is going to prematurely fail. So, in instances where your collector current is not going to exceed the 50 milliamps, this is a great replacement for this, because these are starting to get very hard to find. You know, these aren't, and any one that you do find is going to be new old stock. They're not manufacturing these anymore. And this is where I say that, you know, just going onto the internet and looking at something and blindly following something that somebody says on the internet is not always a good idea. If you go on to Audio Karma, or you go on to a lot of places with forums and so forth, there will be people that will make lists of transistors that can replace other transistors. And quite often, they're speaking in the context of the application that they were using it for. So for instance, if I know that that transistor is not going to have to conduct more than 50 milliamps of collector current, I would say that this is a good replacement or substitute for this. But if you just take that as the final word and you blindly plug one of these in place of one of these, and you don't look at the circuit that you're using it in, you could have a problem. So this is where I say, do your research. Never trust something you just see on the internet, because it may not always be right. Now, where am I talking to you from? I'm on the internet. So I'm telling you not even to listen to everything I say. I say this in a lot of my videos, but it's the truth. Because sometimes there will be an application or a situation where what you hear is not necessarily going to be true for your situation. Do your research. That's all I'm saying. So, back to this, okay? Can we replace these 2SA 970s? The other thing is, before I get to that, there's another transistor called a KSA 733, and it has a 150 milliamp current, but it only has 250 milliwatt maximum dissipation. So even though this can handle higher current, it handles half the voltage and can dissipate a lower amount of heat in milliwatts. So in other instances, if it's going to be, remember we used an example of 20 volts. If we only had 20 volts, collector to base and collector to emitter, but we had that 60 milliamps, this would be just fine, because we would still be lower than this, and we would be below all of these, and that would be a good transistor. And again, similar specs, everywhere else. So once again, it would work. So back to this. What would we use? Well, in this instance, if you look at the schematic, and let me see if I have one handy for you. First of all, the power supply, when you get back into this section, some of these, like in the differential pair and so forth, over in this section here, these transistors are all working off of this regulated, what is this, a 15 volt supply or 14 volt supply. And the ones that are going to be exposed to the full rail voltage, which is about 67 volts, you can see that, 66.7 volts. You're going to have current limiting, and you're going to have a lot of voltage drop. You can see 64 volts through these resistors. And if we do some math in here, let's say this was just a dead short to ground, which it's not, because we have other components in here. But if you take 67 volts, right, and divide it by 2200 ohms, you have 30 milliamps. So what we're saying is, if this directly referenced itself to ground, this would still limit that current to 30 milliamps. So you're not going to exceed that 50 milliamp of emitter current. So, or collector current, let's say, because of course the circuit, this is just going to act like a voltage drop, but pretty much the current up here is going to be the same as the current down here, with the exception of the little tiny bit of base current that'll be flowing through there as well. So this is safe, and we can replace it with the KSA 992. Those are some of the things you look at when you're replacing transistors, because again, you're not going to find these two SA970s unless you find new old stock. And those are going to get expensive, and they're going to get hard to find. The other thing you have to watch out for is the pinout. Some transistors, for instance, we looked at this KSA 733. Well, a KSA 733 is emitter base collector. And if you look on these ones, like the KSA 992 and the 2SA 970, they are emitter collector base. Now, if you get a KSA 733C, you see that right there? That means that you're going to have emitter collector base, which is the correct pinout. If you go on DigiKey and Mouser and you just search for the 733s, you will probably find these. But if you try to find a 733C, it'll say out of production, obsolete, no longer in, and you may be able to find some marketplace ones or some ones on eBay or someplace that sell them, but they're usually going to be a back order, and they're going to be expensive, and you may have to order many of them, like thousands of them, in order to place an order. So these are all things you have to be aware of. Okay, so I get a lot of, the reason I'm saying all this is I get a lot of question about these transistors, and everybody says, can you just show me how to choose a replacement transistor? Well, this is how you do it. And yes, it is a little bit complicated, because you have to take the time to look at the components, look at the circuit that you're using it in, and then find the closest match you can get. Now, there is a website that can help you with this, but not always, and I'll show it to you here. Okay, here's this little website called alltransistors.com. So it's just alltransistors.com. And when you go there, it comes up with this page, and all you have to do is type in a transistor. So for instance, let's say, do you remember we replaced this 2SD 757, which is this little transistor right here. Focus. All right, so 2SD 757. And all we need to do is go there and type in 2SD 757. And it doesn't give you a full data sheet, but it will give you, there it is, a result. If you click on it, it doesn't give you the full data sheet, but it does give you the basic specs of the transistor. So you can see that it is a silicon transistor, it's NPN. It has a maximum collector dissipation of 1.25 watts. Collector base and collector emitter are 160 volt maximum. This is also a 50 milliamps for collector current. Now how about that? Much larger transistor than that little 2SA or KSA 998, but remember it has a lot more dissipation, but the same collector current, 50 milliamps, that's it. Transition frequency is 140 megahertz. So there you go. Now, if you scroll down, it says the package, the case that it comes in, that's what that means, is a TO220. And right off the bat, we can see that that's not correct. So if we just take that at face value, we're already being led down the rabbit hole, because there's a difference between a, so here is a TO220 case. I don't know if you can see that. That's a TO220. This is not a TO220. They are very different. You can see the side profile of it and see the side profile of this. They are very different. Okay. And this is called a TO202 case. You can see the tab comes out the middle. The back of the case is plastic. It's not metal. You see that? So the tab comes out the top. This one, the whole back of the case is a heat spreader. It's a much heavier duty design. So right off the bat, it's misleading us. And if I go down here though, and I click on 2SD757 equivalent, you can see that it lists all of those characteristics that we saw in the data sheet, you know, earlier on the last page. It puts it into these little search boxes. See that? And what's going to happen is it's going to search for every transistor that has a similar characteristic to that that's in this website's database. So this is a great resource, right? But if I scroll down and look at all of these, look how many they show. It goes on and on and on of different transistors that are potential replacements. But if you look at all the voltages and so forth, they're not exactly the same. You can see how they're all similar but different. So for instance, the VCE on this one is 450 volts. A lot different, isn't it? The watts, okay, so the case temperature or the dissipation, much higher on these. Look, 40 watts, 50 watts, 40 watts. And the problem is it did the search based on transistors that are in a TO220 case. See that there? So essentially, it gave you a whole list of the wrong transistors to replace this with. Very, very bad. Okay? So this is another instance where, you know, people say, hey, I go on this website and it tells me all the replacements for a transistor. Don't trust it. Now, sometimes this website can work very well. So let's say we do, let's look for one of those 2SA 970s. How's that? 2SA 970. And you can see it's right there. And right away, you can see it's a TO92 case, which is correct. If I click on that, there's the specs. And if we compare it to our actual data sheet that we have, let's see if I can find it. Where did it get buried? It's under here. There it is. Okay, and we'll compare, and you can see 300 milliwatts, which is correct. 120 volts, correct. 5 volts, correct. 100 milliamps for the collector current. That's correct. So this is the correct specs for that transistor. And if I go down here and I do transistor equivalent substitute, and I scroll down here, not a very big list, but here are the transistors that are, I will say, potential substitutes. And you can see one of the closest ones that we have is a little bit better spec, but it's basically the same transistor with a little higher. This one's got a higher HFE or beta, is the 2SA1191. Okay, if we go down to the bottom here, here's a couple other ones that might be good replacements, and that's the KTA 1268 and the KTA 2400, and those ones we can probably still get a hold of. They should be fairly available. And of course there's your 2SA 970, which is a direct replacement. Just about, or it is, because it's the same transistor. And then it has the 2SA 970BL, the 970GR, and the main difference in those is going to be the gain. So you can see all the different things. But while I wouldn't just take this website as the end-all answer, this narrows down your search quite a bit, and then you can go find the data sheets online and compare to see if they will work. So this is the way that one of the methods that I will use when I'm really stumped. And it seems like this alltransistors.com seems to have a much larger database of even some of the strange transistors out there that you don't see anywhere else on the internet or many other places. So again, it's a good resource, but you have to do your research. Okay, so that was anyway a long-winded explanation of how I do this for replacing these transistors. It's not always a really quick thing, and in the microwave society in which we live, everybody just wants an instant answer to everything, you know. Don't talk, don't show me how, don't teach me anything, just give me the answer and let me jump ahead and do it. Well, unfortunately, you're going to be disappointed in life if you try to do electronics that way, because you just have to do your work sometimes. There's no way around it, no other way around it. Maybe you should probably pick a different hobby if you don't have the patience for it, I guess is what I'm saying. So I'm going to replace these two transistors simply because I have it all out anyway, and because I replaced them on the other one. These ones are all going to be good. I'm going to leave them alone. These 970s are very good transistors. And then we're going to clean up the heat sink over here a little bit, just to get rid of that white goop around there. And then we're going to measure the last, I checked this whole section of resistors. They're all perfect. And I checked all the diodes. They're good. I'll check these last few resistors, and I'll be right back, and we'll be ready to try this thing out. Okay, it's all done. Cleaned up the back of the board. And this transistor here is a very interesting one. This is a 2SC1568. And where is that transistor, you might ask? It's actually right here. It's not even listed on the schematic. So this is a schematic for the entire amplifier section. And if you look down here, here's your emitter, collector, and base. They go straight down into here. Let me see if I have a different printout of that. I think I do. No, maybe not. I thought I had some other printouts of that, but I don't. Unfortunately. I thought I had one where I highlighted that. But essentially, this goes right into the bias circuit. It's part of your bias circuit and part of your thermal tracking. So you can't just replace it with any transistor. You have to have this. I do have a few of these 1568s in stock, brand new old stock. But hopefully these will never go bad. The one on the other one was good, and this one is good. I don't know how the other one survived without getting totally trashed, considering the whole board, just about everything on that board burned up. But this is part of your thermal tracking, and it has to be that specific transistor. So just remember, if you need to replace that, you're probably going to have to try to find a new old stock, or there was a couple of transistors that I found that probably would work for that, but would be, I don't know, close, but might not track the same. Anyway, this is all together and cleaned up. Let's put it together. We still have to replace the outputs. Now, these are 4 good outputs. They are still working, even though they're kind of corroded and gross looking. But I want to replace these with the same ones that I have on the other side. They're much heavier duty, the new ones anyway, which is these MJ21195 and MJ21196. So we'll get those mounted up, and then we'll be all set to install this and try it. Okay, removing this transistor, it is a 2SD, so that should be an NPN, and the 2SB should be the PNP. And facing it this way, so the long side facing me, if I put the P on the base should be on the left. And if I go from that to the collector, there should be a voltage drop, and you can see there is. Can you see that? Voltage drop, and it's 495 millivolts. And then if I go to the emitter, it should be a little bit higher, and it is. So that's how you can tell the difference between the emitter and the collector, is the voltage drop. So this is a good transistor. So I'll clean these ones up. Usually some of these ones that are a little harder to find and that are no longer in production, if they're still good, I'll clean them up and I will keep them, because sometimes, you know, an amp will come in, somebody will have one that just needs to have something replaced, just a single part, and rather than doing a wholesale restoration, if I have a spare transistor like this that's the correct one, we can just install that and get it back up and running without doing a full replacement or restoration or whatever. So that's what I'm going to do with this. And I think, like I said, all 4 of these are good because I tested this amp and it works. And what we're going to try to do maybe is something a little different. Instead of plugging this into the amplifier to test it, I'll get out a couple of my larger bench power supplies, and we'll try to power this thing from a bench power supply and test it on the bench rather than connecting it into the amplifier. Because I don't think you need any other connections other than the power, you know, and signal input and speaker output. So we can probably just use crocodile jumpers, or alligator jumpers, or whatever you want to call them, and do this on the bench. So we'll clean this thing off. And these are both NPNs. So we'll take them both out. We'll test this one also. It's strange, I get, you know, everybody has different likes. Some people like the videos that are real long, and it's almost like a relaxing thing to watch. And some people just want you to show them how to replace something and fix it because they want to fix their own, and they don't want to bother learning anything. They're looking for a quick answer. I'm not really a good one for that. And part of that comes from my job. You know, you have to make sure that everybody understands, you know, what the rules are and how things properly work and everything, because it's really important, you know, because it's medical equipment and so forth. And quite often I'm charged with the task of training someone how to do this stuff. So you have to try to cover all your bases. So you end up just taking your time and explaining everything. And although I'm not a full-time instructor, I have taught classes over the years, and probably, well, definitely that's what I'm going to do in my retirement, because there is an x-ray school that's only about an hour from here. It's one of the only ones in the United States that's dedicated to that. And I will probably, I've already talked about maybe doing that there as a retirement gig when I get tired of traveling around and running a business and all that. But who knows? I might just end up doing this, playing with stereos. That's not so bad either, and I don't have to leave my house. But I will tell you, whatever I do, it'll be because I want to do it, not because I have to do it at that point in time, which will make it a lot more palatable. Having to get up every day is a little different than wanting to get up every day and do a job. But I really don't mind what I do. I like what I do. It can be stressful sometimes, and I don't like always the travel all the time, but you know, beyond that, it's not bad. And we're going to use some new mica pads. And yes, I have sill pads too. And again, I have no answer. Why am I using this? And you know, and I could use a sill pad. Just, I guess because I want to. And, you know, give it the little vintage look. Well, Tony, why didn't you give the vintage look to those TO220 transistors that you put sill pads on? Again, I don't know. Just because I felt like it, I guess. Doesn't really matter. People get all uptight about all this stuff, but at the end of the day, it doesn't make that big of a difference, really. As long as it's good quality and you know, you get the right stuff. Use the, you know, good sill pads or good mica pads and good thermal grease. You know, that's what's important. And this stuff isn't as high performance grease as you would use like on some computer equipment and stuff, because some of the computer equipment really gets kind of, let's see here, I think I'm good. Yeah. It has to dissipate a lot of heat, or transfer a lot of heat, I should say, compared to these transistors. I mean, if you ever see some of the CPUs out there nowadays, they just get incredibly hot. And it's quite a task to keep them cool. MJ21195. I think that's the PNP. I can't remember. I have to test it. I could probably look it up, but it's just as easy to check it out here. Okay, what's the rule again? NPN, PNP. The middle letter tells you what polarity to put the base on, right? So if this is NPN, the P should be connected to the base, and we know if we hold the transistor this way, this is the base, and you can see this is the PNP. See that? So the MJ21195 is the PNP. So we need the MJ21196, which is this one. right? And let's test it. Am I boring you guys to death yet? There we go. Perfect. All right. Normally I would spread this on there real neat and everything, but I'm not going to today. It'll squish itself out. This is really good grease here. I don't even remember where I got it from, but it spreads really well. And I don't know, it does a really good job of heat transfer. It doesn't seem to dry out. It's just easy stuff to work with as far as heatsink grease goes. So that is what we're going to use. So let's plug this back in. There we go. And we'll start the screws. You can see that stuff spreads out as soon as you tighten the screws down. You don't want to really over tighten it because this is just threaded through that little metal plate on the back of that socket. You can see that's just, there's your thread, so you don't want to really crush it too hard. Okay, let's put our other 21196 in there. Probably putting a little too much of this stuff in there, but it'll squish out and then I'll just clean it off if it's too much. Rather have a little bit too much. The idea is you don't want it floating on top of the grease. You want the grease to kind of squish down into all the little pores and all the little imperfections, but other than that, you don't want it really floating on top of a pool of that heatsink grease. That's why I like this thinner stuff, because it spreads out a lot better. Macintosh and some of the other ones back a long time ago used a clear grease that's almost like watery, like the glue kind of thing, and I noticed it really spreads out thin. It's good stuff, but I've never seen it like commercially available around here anyway. If any of you know what that is, let me know, but it's pretty cool stuff from what I've seen. And it doesn't seem to go bad. It lasts a very long time, but it'll deceive you because it's the first couple times I saw it, I didn't think it was very good, and I thought, wow, it's stuff all dried out and there's nothing left, and that's not the truth. It actually was that thermal compound. It was good stuff. So, okay. So you can see it's squished out a little bit. And you can leave that like that, but I'll usually take the extra time like this and I'll clean it around it to make it look a little neater as I make a big mess here. But I just don't like this stuff out there, because if for the end user, it doesn't really matter, because they're not going to see this. It'll be inside the amplifier. But hey, if you go to service this grease is all over everything. It just gets all over you when you're trying to work on it, and that's a pain in the butt. So I clean it up. Just, taking pride in your work is what it's about. Not that I do the best work. I see some videos out there, some things that people do, and it's like ridiculous how extreme they go to make it totally perfect, which is cool. But I guess you get to a point sometimes where you just don't, you have to weigh the amount of time something's going to take versus the benefit of it looking neater or whatever. And again, if you got the time and can do it right, that's the way to go. But if you don't, then you just have to make sure you do the important stuff. You know. All right, there it is. I'm going to do this one just the same, and then I'll be right back. Okay, we're only going to run this at half power because my power supply only goes up to 35 volts instead of 65 volts. And I do have 55 volt supplies, but they're single ones, and you can't really, they're not easy to combine. Let's just put it that way. So we're just going to do this, and I just want to see if we can adjust the DC offset and do anything with the bias, or if we're getting any bias whatsoever. All right, so we're at plus and minus 30. We're only drawing about 10 milliamps of quiescent current. And you can see there's a tiny little DC offset. And I just want to see if it's adjustable to see if it's real. Oh yeah, look at that. Right on. So less than 1 millivolt. Okay, so let's go and check for our bias. Again, this is with different transistors on the output and everything. Now I don't know if I'm going to have enough, I'm probably not going to have enough voltage to get any kind of bias on here, but I just want to see if it does anything. No, it's not going to. So I'm going to have to get a little more energy on there before I can read anything, but we are getting something at least. And I could probably poke around and see if we have any kind of voltage anywhere. So let's go on the ground. And sometimes it's easier to bench test something than to try to test it in the amplifier. Of course, you can't align it and everything, but... And I don't have these hooked up, and I'm not really sure how necessary those are, but okay, so here's base voltage on the driver, 455 millivolts, 510 millivolts. That's cool. Let's go to the emitter, and the emitter and the collector should be your B plus voltage and B minus voltage. Okay, so far so good. And then if I look here, I should be able to read this voltage drop across this bias spreader diode, and I have about 1.5. It's low. So that tells me we just don't have enough voltage on here to fully test that part of the amp, but it is working. There are no shorts. And this tells us that the amplifier is safe to power up, and we don't have to worry about anything failing, at least for the most part. Okay, let me shut that off. I now have my signal generator, and I'm just going to put a 100 millivolt signal in there and see what kind of output we get, if we get any kind of a sine wave output. So let's go up to the oscilloscope. All right, turn on. Wow, look at that. Perfect. Absolutely perfect. And that's at the speaker terminals right there. Now, of course, I don't have any load on here. If we put a load on there, it would draw a lot of current from our power supply, and I don't want to do that right now. But at least unloaded, the amplifier works. And it's drawing very low current, so I don't even have to worry about if it's getting warm or not. It can't be because we're only drawing 10 milliamps. And it all looks good. And if I Yeah, I can go way up on this. Let's see. Move the scale down. Just see if it'll keep going till we hit the rails. Should be hitting, there it is. And it actually clips very symmetrically. Look at that. Excellent. Okay, so turn that off. Let's get it mounted in the amp. Well, before I put the other amplifier module in, I better take care of the elephant in the middle of the room. And as you can see, this is badly rusted on the back. And it's weird because the front part of the amp isn't that bad. I have a feeling because this thing came without a case around it, and the side screws were really badly like scratched up and damaged, the heads were damaged like it had been pushed in and out of a rack. I think somebody actually had this in a rack and was doing something like DJing with it or playing out live with it. This was not a fine piece of audiophile equipment in somebody's listening room. This thing was thrown in a rack, I think, and abused for many years. And I think this is part of the result of it. Unfortunately, all we can do is I can clean some of this up, maybe wire brush some of the rust off, but I have to watch that I don't remove any of the screen printing on there. So it's not going to look perfect, but I can probably do something and maybe color it in a little bit with just some very light paint or something. It's never going to look perfect unless you have a complete, restoration of the back panel, spray it, and then rescreen it. I'm not going to do that. So we'll do the best we can, and when I'm done, I'll show you what I've done. Well, I've done a little bit of derusting here, and I got it down to a point where it's not as bad as it was. There is good metal underneath there, even though it was some pretty thick rust. And it seems like only one of the RCA jacks did not clean up perfectly because the plating was kind of corroded on it. These speaker terminals aren't the greatest either. They're kind of pitted inside, so I don't know if I'm going to possibly cut out a blank plate in there and then put actual banana connectors or whatever you want to call them, because I think that would be better anyway than these things where you spring-loaded stick the wires in. So I do have a little bit of work to do on this. I did replace the fuse holder, as the old one was really bad. It was just broken. Again, it looks like somebody, you can see how this is all snapped off and everything. I couldn't get it apart. It's just this thing's been abused. So going to have to do some maintenance on this back panel before I can put this amp in, because this would just be in the way working around here, so I'm going to leave that out for now. So I think that's going to end this video for this episode, and when we come back, I'll have this cleaned up as best I can, and it's not going to look brand new. Because it needs to be protected, I am probably going to put a thin coat of black paint and maybe even shoot a little bit of lacquer over it. I don't know. And then just to keep what we have here left intact. So we're going to do that, and then we'll put the amp in and check it all out. Then we'll have to go to the front and work on the preamp. So that is it for this episode. I did make up a couple of jumpers to go between the preamp out and main amp in, because you need those in order for the preamp to work. And that's it for right now. So until next episode, I wish you all peace, joy, happiness, and good health in your lives. And we'll see you again real soon. And thanks a lot for coming along for the ride. Take care, everybody, and have a great week. Bye-bye.